Okay, so in this video, I'm going to show you how to solve higher degree polynomial equations. So the technique we're going to use is factoring to find solutions to these equations. So these are the two examples I'll be working on in this video. So let's check them out. So for this first equation, we're going to use the method of GCF to pull out the common factor and then we factor. So between these three terms, we see that the GCF happens to be x squared. So I'm going to take out an x squared, and then we have x squared minus x minus 6 equals to 0. So this is what we get when we factor. And now we can factor this a little bit more. So that can be factored as follows. So we still have an x squared. And then for this term, we can factor into x minus 3 and x plus 2. So you could use the AC method, but you can just use trial and error and guess your factors. So you look for two numbers. When you multiply them, you get -6. So that's -3 times 2. And then I also see that -3 plus 2 gives us -1. So these are the numbers that will do the job. And then we set it equal to 0. So we set now each factors equal to 0. So we have x squared is equal to 0. Then we have x minus 3 equals to 0. And then lastly, we have x plus 2 equals to 0. And now by solving each of these independently, for the first one, you can say, you can take the square root of 0 and you know you get only 0. So the first one gives us only one solution. Second one, we add 3 to both sides, so we get x is equal to 3. And the last one, we subtract 2, so we get x is equal to -2. So there you have three solutions, but remember that this solution, x equals 0, is a repeated solution because of the degree 2. So it's x squared is equal to 0, so it's a repeated solution. So our solution is really 0, -2, and 3. So even if it's repeated, you don't have to write it twice. It's understood. Just know that it is a repeated solution. All right, so that's the solution to the first equation. Now let's take a look at the next one. So for this one, we will also use factoring method to find all solutions, but to make things look less complicated, we're going to use a substitution. So what I notice is that this is exactly same as that. So why don't we introduce a variable and come up with a substitution? So we can say, okay, let some variable t replace 4x plus 7. So everywhere you see 4x plus 7, you replace it with this variable t. So then our equation now becomes t to the fourth minus, and then 4x plus 7 replaced with t, so that would be t to the third equals to 0. And now we can use factoring. So I'm going to pull out their GCF. So this will be t to the third, and then t minus 1 equals to 0. Great. So now we set each factor is equal to 0. So we have t to the third equals to 0. And then we also have t minus 1 equals to 0. And now we can simply solve for t by taking cube roots for the first one. So we take a cube root on both sides. So that will give us, cube root of 0 is 0. So we know t is equal to 0 for the first equation. Second one, we add 1 to both sides. So we get t is equal to 1. Great. But we're not looking for solution in t variable. We're looking for solution in x variable. So now you substitute back what the original question was. So originally you have this replaced with t. So I'm going to substitute that back with my t variable I just found. So I know t is equal to 4x plus 7. So now substitute back, t is equal to 4x plus 7. So we have 4x plus 7 is equal to 0. And then here we have 4x plus 7 is equal to 1. So simply substituting what t was. Well, now I can continue to solve because these are two linear equations. So for the first one, if we continue to solve, we subtract 7 on both sides. We get 4x is equal to negative 7. And then we divide by 4. So we have x is equal to negative 7 over 4. That's one solution. And then we do similar procedure on the second one, subtract 7, because we want to isolate x. So we have 4x is equal to negative 6. And then we divide by 4 on both sides. So we have x is equal to negative 6 over 4, which will simplify to negative 3 over 2. So there we have our solutions to this equation. All right, so I hope this makes sense. I'll see you next time.